Fatima, am I audible?
Yes, sir.
Okay, so basically in the last class, we had covered up to this. Do you have any doubt in this question? Then we will start a new topic that is basically the fourth colligative property, osmotic pressure. So, did you solve this question? Let me
Yes,
know.
sir.
Okay. So, what was your answer? Basically, molarity is equal to
32.05.
32.05 molarity. Very good. So, I'm going to start the fourth colligative property, that is osmotic pressure. And before osmotic pressure, we need to understand what is osmosis, that we already know from previous class. What is osmosis? So I'm going to make a diagram to explain osmosis. See, there is a container which is divided into two parts with the help of a boundary or a membrane. This membrane is called SPM, that means semi-permeable membrane. That means semi-permeable membrane. Semi-permeable membrane. And you also need to know this semi-permeable membrane allows only solvent to pass through them. Allows only solvent to pass through them. To pass through them. It is also important to note that the size of solvent is smaller than the size of solute. That's why solvent can easily pass through this membrane. Now see, there is a solution on the left hand side, and just call it C1, that means concentration 1, C1, and C2. Concentration on the left hand side of the container, left chamber is C1, and on the right chamber it's C2. And let's say concentration in C1 is greater than C2. Whenever we talk about concentration of solution, that means we are talking about the concentration of solute. Since in solution we have two components, the one is solute and the other is solvent. But whenever we talk about concentration of solution, that means we are talking about the concentration of solute. Are you getting my point? Fatima?
Yes, sir.
Now see, if I'll ask you, the solution or the solution is concentrated. That means the quantity of solute is very high. That's why it is concentrated. So as you know that solute plus solvent is equal to solution. And if concentration on the left hand side is greater than concentration on the right hand side, that means solute on the left hand side, solute on the left chamber is greater than solute on the right chamber. That also means solvent on the left hand side is lesser than solvent on the right hand side. If the quantity of solute is greater here, that means solvent is lesser. If the quantity of solute is lesser here on the right chamber, that means uh, solvent is greater on the right chamber. So you know that this solution or the solvent will always flow from higher concentration to lower concentration. So if solvent is greater here and solvent is lesser here, that means it will go right to left. So we are going to define osmosis in two terms. The first one is solvent in terms of solvent, and the second one is in terms of solute or solution. So I'm going to define it. Just see, look at the definition. The movement of solvent molecules from their higher concentration, that means higher concentration of solution, a solvent. We are talking about higher concentration to lower concentration, of solvent. This is in terms of solvent. And the second definition is the movement of solvent molecules from lower concentration, of solution. That means in that side solute is lesser, that means solvent is greater. Solution, lower concentration of solution to higher concentration of solution, higher concentration of solution through semi-permeable membrane, through SPM. That means you can also write here through SPM. This is called basically SPM, that means semi-permeable membrane. Please write it.
Done, sir.
Very good. So we know what is osmosis. Basically, higher concentration, where there is higher concentration of solvent, will flow from there to lower concentration of solvent. And in terms of concentration of solution or concentration of solute, we talk where there is lower concentration of solution, that means there is lower concentration of solute, that means higher concentration of solvent to higher lower concentration of solution to higher concentration of solution. Now we will go for osmotic pressure, and for osmotic pressure I am going to make a diagram. Please do it with me. See here, it's PATM, that means atmospheric pressure is applying, and here it is piston. This is piston that you can adjust according to your self, and here it is SPM, that means semi-permeable membrane. This is SPM, semi-permeable membrane, and its characteristic is that only solvent can pass through this because the size of solvent molecules is smaller than the solute. Also, on the left chamber, this is solution, and on the right chamber, pure solvent. Only solvent is present. So please write it and let me know when you are done with this diagram.
Done, sir.
Very good. So answer me some of my questions. Like, what do you think? The flow will from pure solvent to solution side, or the flow of particles will from solutions to pure solvent side? Or else you can answer me this question: in which side, right side or left side, where will be the number of solvent molecules will be higher?
In the
Where is
left side.
on the left side? On the left side, it is solution. That means solute and solvent both are present. Yes or no?
Yes,
Tell me.
sir.
Solute and solvent both are present. And on the right hand side, it's pure solvent, and the chamber is equal in area. That means the solvent, uh, mm, the particles of the solvent will be higher on the right hand side or not? Tell me, Fatima. What do you think? Where is solvent more, left or right? Since on the right hand side it's pure solvent, only solvent is there, but on the left hand side it is solution. That means solute is also involved.
On
So we
the
can think of on the right hand side, solvent is more. The concentration of solvent is greater on the right hand side. So the movement will be from right to left. Yes or no? If you have two container, one of the container is fulfilled with water, and one of the container is mm, empty. So if you are going to connect a pipe, the flow of water will be left to right. In the same way, where there will be higher concentration, that will flow from higher concentration to lower concentration, and through this semi permeable membrane only solvent can pass through. And here solvent is, concentration of solvent on the left hand side is lower, and concentration of solvent on the right hand side is greater. That's why it will flow from right to left. Yes or no? You are not audible. Is this understood?
yes, sir.
Now see, the flow of water molecules or pure solvent from right to left. Okay, and what is osmotic pressure? So the flow will take place from right to left, and here is the piston where you can adjust the pressure, or you can call it where you can adjust the flow of flow of solvent from right to left. Now, if this is piston, I am going to apply some pressure here so that the movement should stop. What is osmotic pressure? The extra pressure or the pressure which is required to apply on the piston over solution side to stop this movement is called osmotic pressure. If there is pressure is equal to you are not applying pressure, that is zero. Here it will be P18, that is atmospheric pressure. But if the concentration on the right hand side, concentration of solvent on the right hand side is greater than concentration of solvent on the left hand side, so the movement will take place. That is called osmosis. But we have piston, so you are going to apply a pressure, that pressure which stops this movement or process, which stops osmosis, that is called osmotic pressure. Is that clear? Fatima?
Yes, sir.
So now I'm going to define osmotic pressure. So what is osmotic pressure? The net movement of solvent molecules from solvent to solution can be stopped by applying an extra pressure. By applying an extra pressure over solution side, over solution side, which stops osmosis, which stops osmosis, is called osmotic pressure, and osmotic pressure is denoted by pi. Please write it. Please let me know when you are done with this. Let me know when you are done with this.
Done, sir.
Now see, this is osmotic pressure. The pressure required to stop osmosis by applying on solution side, that pressure is called osmotic pressure. Now we are going to derive a formula in the same way that we have derived in the last class. So here it is. Experimentally, we found that pi is directly proportional to molarity, and the second quantity pi is directly proportional to temperature. So if you are going to combine this, it will be pi directly proportional to m t, and if you are going to remove the proportionalities and we are going to use a constant, that is gas constant, rmt, or sometimes it is known as mrt, you can write it. And pi is also equals to m can be replaced by crt. In some books m is denoted as c. Now I'm going to tell you what is pi. Pi is basically osmotic pressure. Osmotic pressure. C or m is basically concentration, that means molarity, concentration, or we can call it molarity. T is temperature. T is temperature, and R is gas constant. R is gas constant. and we use its value 0.0821. 0.0821. We are going to use this formula much. Please write it, and if you have any doubt, please ask. Let me know when you are done with this.
Done, sir.
Very good. So, are you prepared for the test? I think that's why uh, all other students are absent because of test paper. Calculate osmotic pressure due to 5% weight by volume sugar solution. Do you know the chemical formula of sugar solution? Have you prepared for the test?
Yes.
Okay. Can you do this question or I should help you? Let me know.
I'm doing it right now.
Okay, very good. Thank you. Let me know when you are done with this. Should I help you?
Is the answer 3.4?
5.
Yes, 3.45 ET.
What is the unit? Since you are talking about pi and you took r as a value of 0.0821, that means 3.45 atm. Very good. Yes, this is the answer. Very good. Now going for the second question. 5% weight by volume sugar solution is isotonic with 0.87% weight by volume urea solution if molar mass of sugar is 342. Calculate molar mass of urea. Calculate molar mass of urea. Do you know what is isotonic means? Do you have any idea of isotonic? What is isotonic? Okay, Fatima, do this question, please. And if you are unable to solve this, then let me know. I will give you hints.
I can't solve. I cannot solve this.
Okay, no problem. See, that's why I was giving you hints. Isotonic, do you know what is isotonic? Isotonic means equal osmotic pressure or same osmotic pressure. Equal or same osmotic pressure. Now see, that means the osmotic pressure of sugar will be equal to osmotic pressure of urea. Are you getting my point? Now, can you apply molarity of sugar into R is constant and temperature will also be constant, will be equal to molarity of urea and R is constant and temperature is constant since they are isotonic. So R will be cancelled by R, T will be cancelled by T. So molarity of sugar will be equal to molarity of urea. Can you do this now? Applying the formula for molarity, yes or no?
I'll try.
Okay, just write and let me know the answer. It's easy if you will go step by step. Let me know if you are unable to solve this. Should I help you?
Yes, sir.
Now see, molarity has a formula: number of moles of solute upon volume of solution in liter. In the same way, uh, you are going to use number of moles of solute. This is for sugar and this is for urea, and volume of solution in liter. Now see, urea as a given, about urea, it is 0.87% weight by volume. That means it means 0.87 gram of urea in 100 ml of solution. In the same way, uh, it was 5% weight by volume. That means 5 gram of solute in 100 ml, 5 gram of sugar in 100 ml of solution. So you can see both both have same volume, 100 ml and 100 ml. So it will be cancelled, and what we have left is number of moles of sugar is equal to number of moles of urea. Do you know the chemical formula of sugar? That is C12H22O11, and it is also given number of moles, that means given mass upon molar mass, and it is also given mass upon molar mass. Now molar mass of sugar is given, and given mass of sugar is 5 gram, that is 5 upon 342, and given mass of urea is 0.87, and we need to calculate molar mass of urea. Please calculate the molar mass of urea. Can you solve this now? Fatima, can you do it? Fatima, this will be like m will be equal to 0.87. I just wrote it wrong. 342. 342 upon 5, that will be equal to approximately 59.9 gram per mole. Fatima, are you done?
Yes, sir.
Very good. Now I'm going to give you another question, the last question. Then I will take this 52. Very easy question it is. Is a new screen shared? Can you do this question number 52?
Yes, sir.
Okay. Please let me know the answer.
Is it option B?
Yes, it is. Very good. So can I change the screen? Option B is the right answer. Uh, Fatima,
Yes, sir.
so this is the question for your test. You are going to write it in a different pages that you will make a PDF and send it to the group. Okay, with
Okay.
name. The Learnivio group. I think you are added in a group chemistry, sensor chemistry G. Okay, and write the way you write in your exams. So I will be back in 5 minutes. Please do this course. I will be here till 8 p.m. Okay. Okay, Fatima.
Yes, sir.
Okay, thank you. Fatima, are you done with these three questions?
No, sir, I'm on the second one.
Okay, take your time. Let me know when you are done with these three questions so that I will slide it down.
So can you scroll down?
Yes, yes. Is it good? Oh, wait a minute.
Sir, I can't see the last option.
Okay, okay. This is the options. Okay.
Yes, sir.
Just let me know when you are done with all the questions.